Let's see overall Maharashtra CET. Candidates who wish to take admission in engineering programs through Maharashtra CET 2017 will have to appear in physics, chemistry, and mathematics papers. Choice. There is no choice among the questions, that is, all the questions have to be answered. The candidates will be provided on OMR, answer sheet, and question booklet. At the end of the paper, candidate will hand over the OMR, answer sheet, and question booklet to the invigilator. No candidate is allowed to leave the examination hall till the end of the examination. Each question with the correct response shall be awarded 1 marks. For maths, it is 2 marks. There is there shall be no negative marking. Examination pattern. Before appearing in the Maharashtra Common Entrance Test, one must know the exam pattern of Maharashtra CET 2017. The relevant details outlining subject which marks for the Maharashtra CET 2017 are as follows. Exam type, that is objective. Question type, multiple choice with 4 options. Choose one correct option. Subject mathematics, marks 100 and number of questions is 50. So it is 2 marks for each question in mathematics. Let's see trends on chapters. Most weightage is generally given for calculus section, that is integration, differentiation and applications. Second most weightage is given to circle and conics chapters. Next is 3D geometry section, which contains the chapter 3D geometry, lines and planes. Tips to be remember. Revision should be begin with these chapters. Try to remember integration, differentiation, trigonometry formula to save valuable calculation time during exams. Truly understand 3D geometry. Concept like direction ratios, etc. This will be useful for lines and planes, and understanding it is easier. Matrix tip, study all the properties of matrix like that of skew symmetric, transpose, determinant, facts, zero matrix, unity matrix, etc. This will be useful for understanding the questions. Binomial and probability distribution should always be the last priority. Circle and conics, remember all the equation, general ones, tangent and normal equation, etc. Alternative way to get the tangent equation through a point is to differentiate the curve equation with respect to x and put the value of the point it is passing through. Let's see some important topics in chapter continuity. Types of discontinuity, removable discontinuity and irremovable discontinuity. Question can be asked from these two topics, which is most probable weightage given in this chapter, and continuity of some standard function like trigonometric function, exponential function and logarithm function. Questions can be also asked from polynomial function, rational function, also constant function. But these three topics, that is trigonometric function, exponential function and logarithm function, is considered to be very important, which can be asked in CET exams. In application of derivatives, question can be asked on tangents and normal, and also theorems like Rolle's theorem and Lagrange's mean value theorem. Also questions on approximations, derivative as a rate measure. Even this contains two topics like instantaneous velocity, also on acceleration. These are some important topics which question can be asked in exams. Let's see differential equation. In differential equation, formation of differential equation is a very important question. In differential equation, variable separable method is found to be very important topic which can give us a weightage for this chapter, and also homogeneous differential equations. Linear differential equation. The most important is the application of differential equations. In this, population growth and growth of bacteria or radioactive, Newton's law of cooling, half-life period, surface area. These all are important questions, important topics which can be asked in examination. In probability distribution, discrete random variables and continuous random variable, which are the two types of random variables. These topics are really important in this chapter. Probability distribution. Probability distribution should be the last priority of the whole maths, which can be revised in the last minute. Also, topics like variance and standard deviation, and also the expected value are really important topics in these chapters. Probability density function and distribution function. These topics have less weightage compared to other these topics. These topics have really lengthy sums, so compared to these topics, probability density function and distribution function can be neglected. In logic, questions on quantifiers and quantified duality switching circuits are very important questions, or we can say a very important topic in logic. And also statements and the truth tables like conjunction, disjunction, negotiation, conditional, and also biconditional are very important topics. The truth table of this all topics is to be remembered, which can be easy. And also in logic, logical connectives, compound statements, and truth tables are very important topics. And also quantifiers and quantify. In logic, topics like logical connectives, compound statements, and truth tables. In truth tables, there are conjunction, disjunctions, negation, conditional, biconditional. Truth tables of all these topics are very important. Remembering all these topics can make your problems easy to solve. And also question based on quantifiers and quantified duality, and also the main topic, that is switching circuit, can be asked in MHT CET examination. In matrices, study all the properties of matrix like that of skew symmetric, transpose, determinant, zero matrix, unity matrix, etc. This will be useful for understanding the questions in the examination, and also the adjoint method to find the cofactors are important topics in this chapter, which can be most probably can ask in examination. In circle and conics, from circle point of view, tangent at a point, condition of tangency, number of tangents for a point, length of tangent, and normal to the circle are some important topics which is most probably asked questions in exam. And in conics point of view, equation of tangent and normal at a point, condition of tangency, tangents in terms of slope, also number of tangents. Properties of conics are very important so that it will be more easier to solve the problem based on conics. Remember all the equation, general ones, tangent and normal equation, etc. Alternate way to get the tangent equation through a point is to differentiate the curve equation with respect to x, but the value of the point it is passing through. The synopsis of matrices. There are many types of matrices. Among those, one is transpose matrices. If A is a given matrix, then transpose of a matrix A is denoted by A transpose, that is A dash, or A transpose, and obtained from A by changing in rows into columns and the columns into rows. For example, if A is equal to 2, 0, 1, 3, minus 2, 4, where the transpose of A will be A transpose equal to 2, 0, 4, 3, minus 2, 4. Properties of transpose of a matrix is A transpose of transpose is equal to A plus B, the whole transpose is equal to A transpose plus B transpose. K into A transpose is equal to K into A transpose, where K is a scalar. A into B transpose is equal to B transpose into A transpose, and A into B into C, the whole transpose is equal to C transpose, B transpose, and A transpose. There's also known as symmetric matrix. A square matrix A is equal to A of ij is called as symmetric if A of ij is equal to A of ji for all I and j. Thus, a square matrix is a symmetric if A transpose is equal to A. This is skew symmetric matrix. A square matrix A is skew symmetric if A of ij is equal to minus of A ij. for all I and j. Since aij is equal to minus of aij for all I and j, so therefore a of 11 is equal to a of 22, a of 33, which is equal to 0. Thus, diagonal elements of skew symmetric matrix are 0. Please note that this is a of ij is equal to a of ij. Inverse of matrix. If A and B are two square matrices of the same order such that AB is equal to BA is equal to I, where I is a unit matrix of the same order, then matrix B is called as the inverse of matrix A and it is denoted by A inverse. That is, A into A inverse is equal to A inverse or A, which is equal to I. Only square matrices have inverse. The inverse matrix exists only if the matrix A is non-singular matrix, that is, which is not equal to 0. The inverse of matrix is unique. We'll see adjoint method. We'll see what is minor. Let A be equal to A of ij, be a square matrix of order n. Then the minor of aij in A is a determinant of the submatrix of order n minus 1, obtained by leaving ith row and the jth column of A, and it is denoted by m of ij. For example, if we take A is equal to minus 2, minus 5, 3 and 4, then m of 11 is equal to minor of A11, which is equal to 4. Same way for m12, that is minor of A12 is equal to minus 5. If we see m11, it's by leaving the R1 and the C1. If you see m12, that is by leaving the R1 and the C2. Similarly for m21 and m22, we get 3 and minus 2, where 3 is by leaving the R2 and the C1, and by m22 is by leaving R2 and C2. We'll see what is cofactor. Let A is equal to A of ij be a square matrix of order n. The cofactor of aij in a is equal to minus 1 raised to I plus j times the determinant of a submatrix of order n minus 1, obtained by leaving ith row and the jth column of A. It is denoted by Cij or Aij. That is, if Aij is equal to cofactor of Aij, which is equal to minus 1 I plus of j, which is Mij, where Mij is a minor of Aij in A. We'll see what is adjoint of a matrix. Let A is equal to A of ij be a square matrix of order n and Aij be a cofactor of Aij in A. Then the transpose of the matrix formed by cofactors of the corresponding elements of A is called as adjoint of A, and it is denoted by adjoint of A. Thus, adjoint of A is equal to A of ij of transpose. We'll see what is inverse by adjoint method. If A be a non-singular matrix of order n, then the inverse of A is given by A inverse is equal to 1 upon determinant of A adjoint into adjoint of A. The determinant of a square matrix of order m in terms of cofactor is given as please know that we can use C or A, any of them. This can be also written as A1 C11 plus A2 A of 12, that is C of 12 plus of A of n into C of n. Properties of adjoints, where A of adjoint A is equal to determinant of A into I. Joint of A into B is equal to adjoint of A adjoint of B. And also adjoint of A transpose is equal to adjoint of A transpose. See what is adjoint of A is equal to determinant of A inverse. Adjoint of A inverse is equal to A upon determinant of A, which is equal to adjoint of A inverse. If A is a square matrix of order n greater than equal to -2, then determinant of adjoint A is equal to determinant of A n minus 1 raised to n minus 1, and adjoint of adjoint A is equal to determinant of A n minus 2 into A. Determinant of adjoint A, that is determinant, which is equal to mod of A raised to n minus 2 the whole square. If A is a square matrix of order n and n, that is n is equal to 2, then adjoint of A is equal to determinant of A and adjoint of adjoint A is equal to A. Let's talk about the synopsis of trigonometric functions. There's something called as a principal solution. The solution of trigonometric equation for a known x for which x is greater than equal to 0 and less than 2 pi are called as principal solution. General solution. The expression involving integer n, which gives all the solution of a trigonometric equation, is called as the general solution. The general solution of the following trigonometric equation are used as a result over here, where we have trigonometric equation as sine theta is equal to 0, and we have general solution, that is for sine theta is equal to 0, which is equal to theta is equal to n pi, where n belongs to set of integers. And similarly, we have for cos theta, tan theta, sine theta is equal to sine alpha, where we have for the general solution of theta. We can use this equation for solving problems or this general solution. The table given is the principal solution, where we see the trigonometric equation, the value of trigonometric equation is positive over here, and the principal solution is given. And even the trigonometric equation for cos x equal to 2 is the same value as the principal solution of sine x is equal to half. Similarly, for other trigonometry equations, is the same. If we see over here, the value of trigonometry equation is negative, that is sine x is equal to minus half, sine x is equal to minus 1 by 2. Even the principal solution for negative changes to 7 pi by 6 and 11 pi by 6. Similarly, for other trigonometry equation, relation between the Cartesian and the polar coordinates. First, if r comma theta are the polar coordinates of the point P in the plane, then its Cartesian coordinate, that is x comma y, are given by x is equal to r cos theta, y is equal to r sin theta. Second, if x comma y are the Cartesian coordinates of the point P whose polar coordinates are r comma theta, then tan theta is equal to y comma x and r is equal to under root x square plus y square, where theta is greater than equal to 0 and less than 2 pi. Solution of triangle. In a triangle ABC, angle CAB, angle ABC and BCA are denoted by ABC respectively, and the sides BC, CA and AB opposite to the angle ABC are denoted by A, B and C. The area of triangle is denoted by triangle and its perimeter by 2s. Therefore, the perimeter of triangle is given as 2s is equal to A plus B plus C. We can apply sine rule, where in sine rule, triangle ABC, in any triangle ABC, it can be given as A upon sine A equal to B upon sine B equal to C upon sine C. Same as cosine rule. That is A square is equal to B square plus C square minus 2BC cos A. That is cos A is equal to B square plus C square minus A square upon 2BC. Same for the cos B. Similarly, we get C square plus A square minus B square upon 2CA. And for cos C, A square plus B square minus C square upon 2AB. Tips, like you can remember any one of this and you can derive any one of this using any one formula. That is, you can remember this formula. Also, you can derive same for cos B and cos C from using this formula. We have projection rule, where A, B and C are the three angles of the triangle and ABC are the corresponding opposite sides of the angles. Projection law, or the formula of the projection, express the algebraic sum of the projection of any two side in terms of the third side. So if we see, we have A is equal to B cos C plus C cos B, where C and B are the angles and small b and small c denotes the side of the triangle. Similarly, we have for B and for also C. Same, we have tangent rule in triangle ABC. The same we use tangent rule or Napier's analogy. Law of tangent, or the tangent rule, which is required for solving the problem on triangle. Tangent rule. This rule can be used for solving the problem on triangles, that is tangent rule or Napier's analogy. This can be used for solving the problems on triangle. Half angle formula. Half angle formulas are used for expressing trigonometric functions of an angle x by 2 in terms of function of angle x or for real x. We have area of triangle also, which can be used for solving problems on triangles. Also Hero's formula. Hero's formula is derived from the perimeter of triangle. This can be used for solving problems on triangle. We have circumradius, where R stands for radius of circumcircle. Where we have formula for R as A of 2 sin A and B and 2 sin B, C upon 2 sin C, and also for AB, the R is equal to ABC upon 4A, 4 delta, where delta stands for area of triangle. And also as in radius, that is small r stands for inner circle of triangle ABC is given over here. Even also this can be used for solving problems based on triangles. Inverse trigonometric function. The principal value, that is the value of an inverse trigonometric function which lies in its principal value branch, is called as a principal value of that inverse trigonometric functions. So we have functions over here, that is y is equal to sin inverse sine inverse x, y is equal to cos inverse x, y is equal to cosec inverse x, y is equal to sec inverse x, and y is equal to tan inverse x, and y is equal to cot inverse x, which we have domain for every function, and also the principal value branches, that is the range for function, that is minus pi by 2 to pi by 2. Similarly, for the cos inverse x, we have minus 1 to 1 and 0 comma pi. Where R stands for real numbers. Let's see synopsis of circle. We're given table over here where standard circle, that is x square plus y square is equal to a square, and general circle x square plus y square 2gx plus 2fy plus c is equal to 0. There are two types of circles in this. Center and radius given as center 0 comma 0 and radius is equal to as a over here. And for general circle, the center is g and minus f, and radius is given as under root of g square plus f square minus c, where c is a constant. Parametric equation. The parametric equation for x square plus y square is equal to a square is given as x is equal to a cos theta and y is equal to a sin theta, where theta is a parameter, where theta lies between greater than equal to 0 and less than equal to pi 2 pi. And for general circle, it is given as x is equal to minus g plus r cos theta, y is equal to minus f r cos theta, where theta lies between greater than equal to 0 and less than equal to 2 pi. Minus g constant can be also written as h, and minus f constant can also written as k. Therefore, the equation changes to x minus h the whole square plus y minus k the whole square equal to r square, where theta is a parameter. Tangent at a point x1, y1 is given as x into x1 plus y into y1 is equal to a square. Same as for the general equation over here. Parameter form of tangent at p theta is given as x cos theta plus y sin theta is equal to a. Normal at point x1 and y1 is normal to a circle at a point P on the circle is a line through the point P perpendicular to the tangent at point P. Point P is also called as a foot of a normal in relation to the normal. Therefore, equation given for standard circle is for normal at point is given as x upon x1 and is equal to y upon y1, and for parameter form is x upon cos theta and y is equal to sin theta. Same as for the general circle. Condition of tangency for line is equal to y is equal to mx plus c is given over here, where this can be used to find c and even the point of contact. Equation of tangent in terms of its slope m is given as y is equal to mx plus minus under root a 1 plus m square. Length of the tangent to form point x1 comma y1 is given as under root of s1 is equal to under root x1 square plus y1 square minus e square. Same as for the general circle. Equation of a right circle is given as x square plus y square is equal to 2a square, and same as for the general circle. Let's see synopsis of continuity. A function f of x is continuous at point x is equal to c in the domain of fx if first, that is fc exists, second, limit x tends to c f of x exists, and the third, limit x tends to c f of x is equal to f of c. If f of x is not continuous at x is equal to c, then f of x is a discontinuous at c. C is called a point of discontinuity of f of x. A real value function f of x is said to have a removable discontinuity at x is equal to c in its domain if limit x tends to c f of x which is not equal to f of c. A real value function f of x is said to have an irremovable discontinuity at x is equal to c in its domain if limit x tends to c from the left hand side of f of x is not equal to limit x tends to c from the right hand side of f of x. The real value function f of x is continuous in interval if it's continuous at every point of interval. Every polynomial function is continuous on R, that is real number. Sine function and cosine function are continuous or real number. Rational function is continuous everywhere except at point where denominator is 0. Where denominator is equal to 0. Logarithm function f of x is equal to log of the base of a of x, where x shall be greater than 0 and a should be greater than 0, should be not equal to 1, is a continuous for x greater than 0. Exponential function f of x is equal to a raised to x, where a should be greater than 0, a should be not equal to 1, is continuous for x belongs to every real number. Let's see synopsis related to differentiation. The derivative of function f at x is equal to a is defined by f dash of a is equal to limit h tends to 0 f of a plus h minus f of a upon h, given limit exists. where h is very small positive or negative increment in a, f of a and f of a plus h be the values of a and a plus h respectively. Differentiability at a point. Let f of x be a real value function defined in an interval of a comma b. If c belongs to a comma b, then f of x is said to be differential or derivable at x is equal to c. If limit x tends to c, f of x minus f of c upon x minus c exists. The limit is called as the derivative or the differential coefficient of the function f of x at x is equal to c, and it is denoted by f dash c or d of f of x upon dx x is equal to c. F of x is differential at x is equal to c. Types of differentiation. Differentiation by first principle. If f of x is given, then f dash x is equal to limit h tends to 0 f of x plus h minus f of x upon h is a derivative of f of x with respect to x, where h is a small increment in x. Differentiation by chain rule. If y is a differential function of u and v is a differential function, sorry, this is u, differentiation by chain rule. If y is a differential function of u is a differential function of v, and v is a differential function of x, then dy by dx is equal to dy by du into du by dv into dv by dx. If y is equal to f of x is a differential function of x such that the inverse function x is equal to f of inverse y exists, then dx by dy is equal to 1 by dy by dx, where dy by dx is not equal to 0. If x is equal to f of t and y is equal to g of t, a differential function of t such that y is a function of x, then dy by dx is equal to dy by dt upon dx upon dt, where dx upon dt is not equal to 0. If f of x and g of x are differential function of x, then the derivative of f of x with respect to g of x is equal to f dash of x upon g dash of x, where g dash of x is not equal to 0. Implicit function of form of x raised to m y raised to n equal to x plus y raised to m plus n, where m and n belongs to real number, always have the first order derivative dy by dx equal to y by x, and the second order derivative d square y upon dx square is equal to 0. If x is equal to f of t and y is equal to g of t, a differential function of t, then d square y upon dx square is equal to f dash t into g dash, that is double derivative g derivative of t, f double derivative of t upon f of derivative of t the whole square. Let's say synopsis on definite integrals. Rule for evaluating definite integrals. We have integral a to b f of x plus minus g of x dx, which get equal to a to b f of x dx plus minus integral a to b g of x and dx. Integral a to b k f of x dx is equal to k into integral a to b f of x dx, where k is a constant. Integral a to b f of x into g dash of x dx equal to f of x g of x a to b minus integral a to b f dash of x into g of x dx. Properties of definite integrals. Integral a to b f of x dx is equal to 0. Integral a to b f of x dx is equal to minus b to a f of x dx. Integral a to b f of x dx is equal to a to c f of x dx plus integral c to b f of x dx, where c is greater than a and less than b. Integral a to b f of x dx is equal to integral a to b f of t dt. Let's see more results on definite integral. Integral 0 to a f of x dx is equal to 0 to a f a minus x dx. Integral a to b f of x dx is equal to a to b f a plus b minus x dx. Integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Integral minus a to a f of x dx is equal to 2 into 0 to a f of x dx if f of x is an even function. For minus a to a f of x dx is equal to 0 if f of x is an odd function. This should be an even function and this should be an odd function.